Graph the equation on a rectangular axis, then use those values to make a polar graph. Ugh, all right. Well, in order for me to graph r cos theta, I know that this has an amplitude of 4, and instead of starting up here and working its way down, it's going to start at the bottom. So you're going to look like u. Period is 2 pi, so repeat right here. You're going to peak out at regular 4 because there's no midline to worry about. So it's going to peak out there. You're going to be at pi over 2 and 3 pi over 2. Okay, it's going to be our mid, I guess. So we work our way up. Okay, we're going to peak out here, come back down, and then bottom out here. All right, so this is going to be interesting graphing this guy, but that's all right. So let's do this. These act as the degrees that spin around. Okay, so if I have 0, 0 is already at -4. So graphing the point 0, I'm sorry, I guess I should say graphing the point -4 in the direction of 0 has me going towards 0, but going backwards 1, 2, 3, 4. So that's point number 1. Now, at pi over 2, which is right here, I'm at 0. What's important to understand is right now, I'm supposed to be going towards, as I spin around, right, I'm supposed to be going towards that pole of 0. So what's happening is I'm right here, okay, and keep in mind, I'm going backwards. Normally we go this way, but now we're going this way. So what's happening is as I move around, as this goes around this way, it's getting closer to my pole. So what's happening is we're here, but now I'm getting closer to my pole like that. So this is where I am at the time being. Okay? So let's go to pi and write out regular 4. So here's pi, here's regular 4, and we're at the same dot. So I'm at 0, pi over 2 right now, and my point is moving further away from the pole as I get closer to 4 pi. So that is my point moving further away from the pole as I get closer to pi. Okay. All right, so here I am right now, taking a break. Taking a little break. At 3 pi over 2, which is u, I'm at 0. So I'm going to go closer to my pole as I correctly spin around clockwise. So wait a minute, I'm just covering my purple line here. Huh, that was a waste. All right, whatever. And now here I am, check. And so I'm going to then graph, as I go to 2 pi, I'm at -4. So I'm going to graph -4, 2 pi. So I'm going to face in the direction of 2 pi again, which is 0, and go back here in the opposite direction. So my blue line is going to cover my red line. Huh. So basically what I did is I spun around once, spun around again, and gave myself a perfect circle, if I knew how to draw one, that kind of hits the pole and -4 on the x-axis. And that is actually what we get here. This is the graph of a circle. If you have something in the form a cos theta, it's going to either live over here or live over there. And if it's a positive, it's going to live over here. And if it's a negative, it's going to live over there. And the number tells you how far out you go. If this was a sine theta, you're going to live up here for a positive sign or live down here for a positive sign. And whatever number that is going to determine how small or big your circle is as long as the one end of the circle is attached to the pole. So that, boys and girls, is how you graph a circle on the polar coordinate plane. Fun!